Giant students, welcome to my YouTube channel. Students, your day, just like everyone else's, is only 24 hours, which is equivalent to 24 into 60 into 60 seconds. I repeat students, your day, just like everyone else's, is only 24 hours. Yet, somehow, certain people seem to be able to squeeze more from that time than others. What it all comes down to is time management. So students, how you choose to plan, how you choose to prioritize, how you choose to spend the hours you have, that's time management. So very be cautious, be prudent of utilizing the available time to the fullest extent possible. Right? Why I am sharing with you all this is because obviously I want you all to use the time available and list your priorities. Do list your priorities and then act accordingly. So with that students, let's begin today's session. Right? Today we are going to discuss the equilibrium of concurrent forces, and in the process, we will discuss a very important theorem, which is Lamy's theorem, and we will be trying to apply that theorem in solving certain numericals. Right? So let's start with equilibrium of concurrent forces. Now, equilibrium, concurrent. Let's discuss these two terms. Equilibrium. It contains two terms. Equi means equal. Brium means balance. So when a body is under the influence of equal balance of forces, then the body is said to be under the influence of equilibrium forces. Right? So the net force acting on a body is 0. Then the body is said to be under the influence of equilibrium forces. So number of forces acting on a body, if the vector sum is 0, it means that the net force acting on the body is 0, so it must be under the influence of equilibrium forces, equal balance of forces. Net force acting towards right must be exactly balanced by the net force acting towards left. Net force acting in the upward direction must be exactly balanced by the net force acting in the downward direction. So a body must be in equilibrium only if the net force acting on the body is 0. So that is when the forces are said to be at equilibrium. Now, concurrent forces. Which forces are known as concurrent forces? All those forces which act at a particular given point, which act at a single point, are known as concurrent forces. Like this is a given point, and here these are the forces which are acting. Suppose it is F1 vector, this is F2 vector, this is suppose F3 vector. Let us consider this to be F4 vector. So these are the forces acting at a particular point O. So F1 vector, F2 vector, F3 vector, F4 vector, they are known as concurrent forces. So let's combine these two terms. Equilibrium of concurrent forces. So these are the forces which are acting at a particular point, so they are the concurrent forces, and these concurrent forces will be in equilibrium only if their vector sum is 0. That is F1 vector plus F2 vector plus F3 vector plus F4 vector is equal to 0. So this is the condition for the equilibrium of concurrent forces. Clear students? So those forces which are acting at a particular point are known as concurrent forces, and if the vector sum of the concurrent forces is 0, then it is said to be the equilibrium of concurrent forces. Now let us consider the case of three concurrent forces, right? So let us assume that F1 vector, F2 vector and F3 vector are the three concurrent forces, obviously acting at a particular point. Suppose this point is O. So all the three forces, F1, F2, F3 are acting at a particular point, so they are known as concurrent forces, right? If it happens that the resultant of F1 and F2 is balanced by F3, that is equal and opposite, then the concurrent forces F1, F2, F3 will be said to be at equilibrium. I will justify this. Suppose students, the resultant of F1 and F2, if these are the two adjacent sides of a parallelogram, then the vector resultant would be given by the diagonal of this parallelogram. So it will be F1 vector plus F2 vector, right? So using parallelogram law of vector addition, first try to get the resultant of F1 vector and F2 vector. So the resultant of F1 vector and F2 vector is like this one. It's indicated by, suppose it is A, it is B, it is C. So the resultant of F1 and F2 is indicated by OB vector, which is F1 vector plus F2 vector. Now if it happens that the resultant of F1 plus F2, that is OB vector, is equal and opposite to that of F3 vector, then the three concurrent forces will be said to be at equilibrium. That is, the three concurrent forces are said to be at equilibrium, or said to be at equilibrium if the resultant of F1 and F2, that is F1 vector plus F2 vector, is equal and opposite to F3 vector. That is, it is equal to in vector form minus F3 vector. Equal sign denotes that the magnitude of F1 plus F2 is equal to the magnitude of F3, and the negative sign suggests that they must be in the opposite direction. That is, the angle between them must be 180 degrees, right? Therefore, F1 vector plus F2 vector plus F3 vector would be equal to 0. So this is the condition for the three concurrent forces to be at equilibrium, right? Again I repeat students, for the three concurrent forces to be at equilibrium, the vector sum of the forces must be equal to 0, and that is feasible only if the resultant of F1 and F2 is equal in magnitude to that of F3 and opposite directed. Then only they will tend to cancel out the effect of each other or nullify the effect of each other. It is only then that the net force acting at point O would be 0. And then we say that the concurrent forces are in equilibrium. Actually students, here I must extend this topic. Actually, in order to understand this on the basis of triangle law of vector addition, one thing you must remember, if these three forces are represented by the three sides of a triangle all taken in the same order, then the vector sum would be 0. So that will also represent the concurrent forces at equilibrium. I will explain. Let's draw this diagram. Let's try to draw this diagram. So what to do is, this is F3, right? Let me draw this diagram over here. This is F3. This is an equal vector. So equal vector means having same magnitude and in the same direction. This is F3 vector. Now this is F1 vector, like this. This is F1 vector. This is F1 vector. These are the equal vectors having same magnitude and parallel direction or angle 0 degree. And this is F2 vector. This is F2 vector, like this. This is suppose F2 vector. Now look, F1, F2, F3. These three vectors are representing the sides of a triangle all taken in the same order. All taken in the same order. In this case, all taken in the clockwise direction. So using triangle law of vector addition, what we get is F1 vector plus F2 vector. F1 vector plus F2 vector. These are the two sides of a triangle taken in the same order, F1 plus F2. Its vector resultant is given by the closing side of the triangle taken in the opposite order. So F1 vector plus F2 vector, it should be equal to F3 vector in the opposite direction. So in the opposite direction means opposite to this F3. So it will be minus F3 vector. Therefore, on rearranging, we will get F1 vector plus F2 vector plus F3 vector is equal to 0. So this is the same result which we have obtained by using this parallelogram law of vector addition. So again I repeat the conclusion, students. If the three forces acting on a body be represented by the three sides of a triangle all in the same order, then the forces must be concurrent forces and must be at equilibrium. Because in such a case, the vector sum of all the forces acting at a particular point will be 0. Right? You can extend it to large number of forces as well. There may be 4 forces acting at a point, 5 different forces acting at a point. So if you generalize this statement, it will be like, if number of forces acting on a body at a particular point be represented by the sides of a polygon all taken in the same order, then all those forces are said to be at equilibrium. Clear, students? So that's the statement. Now let's discuss a very, very important concept, which is Lamy's theorem. Let's discuss that and then we will discuss its usage as well. Okay, Lamy's theorem. It is also based on the equilibrium of forces only. Actually, Lamy's theorem is applicable for 3 forces acting at a point on a body which are at equilibrium, right? So let's discuss Lamy's theorem. Okay, first and foremost, it is applicable for a body which is under the influence of 3 forces acting at a particular point and at equilibrium. It is applicable for 3 forces. Which type of forces? Concurrent forces. It is applicable for 3 forces which are acting at a particular point, that is concurrent forces, which are at equilibrium. So Lamy's theorem is applicable for the concurrent forces which are at equilibrium. That is, the vector sum must be 0. Right? Now, regarding the statement of Lamy's theorem, that I will explain. Suppose, students, this is F1 vector. Let us consider this to be F2 vector. And let us consider this to be F3 vector. Clear? Suppose the angle between F2 and F3 is alpha. The angle between F1 and F3 is beta. And let us consider the angle between F1 and F2 is gamma. In that case, if F1, F2, F3 are at equilibrium and are acting at the same point O, then it is found that the magnitude of a force is directly proportional to the sine of the angle between the other 2 forces. So F1 would be proportional to sine alpha. Clear, students? That is, F1 is equal to, say, K sine alpha, or F1 by sine alpha is equal to K. Right? Now if you consider F2, statement is the magnitude of a force is directly proportional to the sine of the angle between the other 2 forces. If you are considering F2, then it will be directly proportional to sine beta. Beta is the angle between F1 and F3. So it will be directly proportional to sine beta. Therefore, F2 by sine beta is equal to K. Similarly, if you consider F3, its magnitude will be directly proportional to the sine of the angle between the forces F1 and F2, which is gamma. So it will be proportional to sine gamma. So in order to eliminate this proportionality sign, we need to introduce some constant, say k. So what do we get is f3 by sine gamma is equal to k. So combining all the three, what do you get? f1 by sine alpha is equal to f2 by sine beta is equal to f3 by sine gamma is equal to constant. So students, this is the mathematical form of Lamy's theorem. Right? Again, I will write down the statement actually. Lamy's theorem states that the magnitude of the force, the magnitude of a force, when the three forces are acting at a point and are at equilibrium, then the magnitude of a force, this is the statement, the magnitude of a force is directly proportional to sine of the angle between the other two forces. So this is the statement, students. This is the statement of Lamy's theorem. And Lamy's theorem is applicable only when the three forces under consideration are concurrent, that is, they must be acting at a given point, isn't it? And they must be at equilibrium. Then Lamy's theorem states that the magnitude of a force is directly proportional to the sine of the angle between the other two forces. So using this statement, we have obtained this mathematical expression. F1 by sine alpha is equal to F2 by sine beta is equal to F3 by sine gamma. Right? We can easily verify this as well by using the concept of cross product. That can be easily done. So let's prove this Lamy's theorem. So let us try to prove Lamy's theorem. Right? So what to do is, let's redraw this diagram. So as I have told, these three vectors can be used to form the sides of a triangle, all taken in the same order because they are all at equilibrium. So what I do is, we can do it like this. This is F3, isn't it? This is F3, this is F2, like this. This is F2 and this is F1, right? Now the angle, students, angle between F1 and F2 is gamma, F1 and F2. Now as I told you, the effective angle between the two given vectors should be at a point, the two vectors should either emanate or the two vectors must terminate at that point, isn't it? So here, the angle between F1 and F2 is gamma. This is the point where the two vectors are emanating or originating. So gamma is the angle between F1 and F2. So between F1 and F2, like this. This is the direction of F2 and this is F1. From here, F2 is emanating and F1 is emanating. So this angle is gamma. So obviously this angle would be 180 minus gamma, isn't it? You need not to write this actually. Now, what about angle F1 and F3? It is beta. Between F1 and F3. Look, this is F1 and this is F3. So this angle is beta. What about F2 and F3? It is alpha. This is F2 and this is F3. This is F3 and this one is F2. So from this point, both the vectors F2 and F3 are emanating. So this is the effective angle and this is alpha. So this is how the diagram gets completed, right? This will be the extension of F3. F3 is directed along this direction. Okay, students. Now, applying triangle law of vector addition. All the three forces are being represented by the sides of a triangle, all taken in the same order. So, using triangle law of vector addition, we can write F1 vector plus F2 vector. It can be written as minus F3 vector, just now as we have discussed. So, let's write it in the vector form. So, applying triangle law of vector addition, we get F2 vector plus F1 vector. F2 vector plus F1 vector is equal to, these are the two sides of a triangle taken in the same order. The resultant of F2 and F1 should be given by this, which is minus F3 vector. This is F3 vector, so it will be given by the closing side of the triangle taken in the opposite order. So it will be minus F3 vector. So rearranging, we get F1 vector plus F2 vector plus F3 vector is equal to null vector. Right? Now students, let's take the cross product. Right? Now what to do is, let's consider F1 vector cross F1 vector plus F2 vector plus F3 vector. So on both the sides we are doing the cross product with F1 vector. So therefore here we get F1 vector cross F1 vector. Obviously it will be null vector plus F1 vector cross F2 vector plus F1 vector cross F3 vector. F1 vector cross the null vector is a null vector, right? So this is a null vector. F1 vector cross F2 vector. It can be written as F3 vector cross F1 vector. As you are aware, students, cross product do not obey commutative law. A cross B is equal to minus B cross A. Therefore, F1 vector cross F2 vector is equal to F3 vector cross F1 vector. Put this as equation number 1. Clear, students? Okay. Now, consider cross product this equation on both the sides by F2 vector cross F1 vector plus F2 vector plus F3 vector is equal to F2 vector cross null vector. Right? Let's keep on solving it. So what we get is F2 vector cross F1 vector plus F2 vector cross F2 vector plus F2 vector cross F3 vector is equal to null vector. Now look, the cross product of a vector with itself is always a null vector, isn't it? So what we get is, here it can be written as minus F1 vector cross F2 vector plus, this is null vector, F2 vector cross F3 vector is equal to null vector. Or students, it can be written as F2 vector cross F3 vector is equal to F1 vector cross F2 vector. Put this as equation B. Simply rearrange the terms. Now what we conclude from A and B, this is F1 cross F2, this is also F1 cross F2. Therefore, from A and B, we conclude that F1 vector cross F2 vector is equal to F2 vector cross F3 vector, which in turn is equal to F3 vector cross F1 vector. Am I clear, students? From A and B, we can conclude this, right? Since they are equal, therefore, their magnitude must be definitely equal. Magnitude of F1 cross F2, it should be equal to magnitude of F2 cross F3, which in turn must be equal to the magnitude of F3 cross F1. Fine, students? Now A cross B is equal to AB sine of the angle between them, isn't it, in magnitude? So here it will give us magnitude of F1 into magnitude of F2 into sine of the angle between them. What is the angle between F1 and F2? The angle between F1 and F2 is gamma. So it will be gamma. It is product of magnitude of F2, F3 into sine of the angle between F2 and F3. What is the angle between F2 and F3? It is alpha. And over here, students, F3, F1 into sine of the angle between F3 and F1. Now, this is F3 and this is F1. The angle between F3 and F1 is beta. So here it will be sine beta. Now students, the last step, divide throughout by f1, f2, f3. I think we should get the result. So dividing throughout, what we get is f1, f2 sine gamma divided by f1, f2, f3. f2, f3 sine alpha divided by f1, f2, f3, which in turn is equal to f3, f1 sine beta divided by f1, f2, f3. So, dividing throughout by f1, f2, f3. What is the ultimate result then? Therefore, what do we get? f1, f2 get cancelled. We are left with sine gamma divided by f3. Here we are left with f2, f3 get cancelled. We are left with sine alpha divided by f1. And in the last term, we are left with sine beta divided by f2. So this is the mathematical statement of Lamy's theorem, which we have mathematically justified and verified. Right? So basically, students, f1 it's directly proportional to sine alpha, f2 it's directly proportional to sine beta, f3 it's directly proportional to sine gamma. So the theoretical statement of Lamy's theorem is, when the three forces are acting at a particular point and are at equilibrium, then the magnitude of a force is directly proportional to the sine of the angle between the other two forces. And from that statement, this is the mathematical statement which we have arrived at. Right? So this can be easily verified using the properties of vector product or cross product. Right, students? Okay, students, after discussing Lamy's theorem theoretically as well as its mathematical verification, now let's apply Lamy's theorem in solving these two questions. In both the questions, students, it is given that the body under consideration is at equilibrium. So Lamy's theorem is applicable definitely, isn't it? So let's try the first question. A mass m, this is mass m, it is hung with light inaccessible string. So the mass of this rod is considered to be negligible. So we are supposed to find out F1 and F2. These are actually, F1 and F2 are actually the tension acting in the string or the rod. Tension is a sort of force, it's actually a force which acts along the length of the string towards the point of suspension. So anyway, this body is at equilibrium. We are supposed to find out the magnitude of F1 and F2. Right? Let's make use of Lamy's theorem. We can make use of Lamy's theorem over here because the body at this point, all the three forces are acting. Here the net force acting is mg. This is the third force acting, which is the weight, isn't it? So all the three forces are acting at the same point. So F1, F2 and mg are concurrent forces. And in the question that's given, it is at equilibrium. Right? So let's find out F1, F2, its magnitude in terms of m. Capital M is given in the question. So this is 90 degrees, students. And this is a horizontal line. This angle would be 30 degree, obviously, alternate near angles. Isn't it? So students, this angle would be 180 minus 30, that would be 150 degree. And this is also 90. So this entire angle would be 90 plus 30, that is 120 degree. So students, let's start with the first question. We are aware of Lamy's theorem, isn't it? If the three concurrent forces acting at a point are at equilibrium, then the magnitude of a force is directly proportional to the sine of the angle between the other two forces. Right? So mathematically what we get is F2 divided by sine of the angle between the other two forces. What is the angle between F1 and mg? It is 90 plus 30, that is 120 degree. So it will be 120 degree. It is equal to, consider mg. If you are considering this force, then this is the angle to be considered, which is the angle between F2 and F1. So it will be sine 150 degree. Right? And it is equal to, let's consider now F1. If you consider F1, then the angle between the other two forces, which is F2 and mg, is 90 degrees. So it will be sine 90. So that's the mathematical statement of Lamy's theorem. Now we can very much make use of it so as to determine the value of F1 and F2, right? So sine 90 is 1. Therefore, F2 by sine 120, it can be written as sine 90 plus 30, right? mg, it can be written as sine 90 plus 60. F1 sine 90 is 1. So F2 divided by sine 90 plus theta is cos theta. It is mg divided by sine 90 plus 60 is cos 60. And it is equal to F1. Right? Let's substitute the value. Cos 30 is root 3 by 2. Like this. Mg. Cos 60 is half. So 1 by 2. It is equal to F1. Therefore, students, F1 would be equal to twice mg. Isn't it? F1 would be equal to twice mg. And what about F2? F2, students, it would be equal to 2 get cancelled. So F2 would be equal to root 3 mg. So this is the answer. So it's pretty simple. So using Lamy's theorem, you can easily get the answer, right? This question could have also been solved using the resolution of vector. Now this F1, it can be resolved in two components, F1 cos 30, F1 sin 30, isn't it? And since this point is at equilibrium, therefore, net force acting in the upward direction should be balanced by the net force acting downward. Net force acting towards left should have been equal and opposite to the net force acting towards right. So, by using resolution of vector also, this question could have been easily done. So, it's up to your wish to either use Lamy's theorem or by using resolution of the vector, right? Okay, students, now let's attempt question number 2. This question also will try to solve using Lamy's theorem, right? We are supposed to find out this angle theta, and this is the point, or rather a body where these three forces are acting. F is given to be 50 Newton along the horizontal direction, W is the weight of the body, which is 60 Newton, and T is the tension, which is again a force which acts along the length of the string towards the point of suspension. Its value is given to be 60 Newton, right? And the three concurrent forces are at equilibrium. It is given in the question. Let's assume that in the question it's given that F, W and T are the concurrent forces which are at equilibrium. Our objective is to find out the value of theta. Let's try to solve it, students. If you draw a line over here, it's a vertical line, isn't it? So, if this is theta, this angle would be also theta. These are the two parallel lines, this will act as a transversal. So, these are the pair of alternate interior angles, right? Okay, so this angle, students, it will be 180 minus theta, isn't it? This angle is 90 degree. And this angle, it will be 90 plus theta. It will be 90 plus theta. So let's make use of Lamy's theorem. So students, 60. Let's consider this force, 60. So it will be directly proportional to the sine of the angle between the other two forces. So what's the angle between T and F? It is 90 plus theta. So it will be sine 90 plus theta. It is equal to, let's say, consider force of 50 Newton. So it will be proportional to the sine of the angle between T and W, which is 180 minus theta. So it will be sine 180 minus theta. Clear, students? So I think by using these two, we can easily get the value of theta. Let's try to solve it. 60 divided by sine 90 plus theta, obviously it is cos theta. 50 divided by sine 180 minus theta, it will be sine theta only. So therefore, sine theta by cos theta is equal to 5 by 6, or tan theta, it is equal to 5 by 6. Therefore, the angle which the string makes with the vertical is tan inverse 5 by 6. So this is the answer, students. So I hope you have understood the applications of Lamy's theorem, isn't it? So I hope you have thoroughly enjoyed this session. In this session, what we have discussed is equilibrium forces, concurrent forces at equilibrium, statement of Lamy's theorem, then its mathematical verification, and last but not the least, we have dealt with these two numericals and solved it using Lamy's theorem. So students, that's it for this particular session. Do join me in my next lecture. Till then, do take very good care of yourself and thank you.